Hello, this is Paul from Foresight Tech. In this video, we are going to deal with the trig limit, which is the foundation for derivatives of trig functions. Let's going to see what the material do we have. Okay, and first we're going to introduce this formula, which is the most important formula, and I will give a proof. And later we have four questions to practice together. All we're talking about in this video is about this formula. Okay, so first, what does this formula mean? This formula is the limit, right? And the function is sin theta over theta. Okay, so can we look at it? If we directly plug theta, okay, we will get the sin at 0, which is 0, 0 with 0, right? What does this mean? This is an indeterminate form we discussed before. Could be any value. This formula gives us the value of this function. This limit is 1. Why? We're going to prove how to prove this. And in the history, we have a very classical method. It's very amazing. You can see super easy. So let me introduce that method to you. Okay, all we need is draw a unit circle first, and the radius is 1, and then we cut the one piece, which is the sector. We have a sector AOB now from a unit circle, so which means OB equals OA is the radius is 1, and then we put the angle theta here, and then we draw vertical line BC, we draw another vertical line AD. Okay, and then E is the middle point of AD, and then link all BE and AB together. Okay, so now what do we have? Let me going to write the results that we need. Okay, we write something that we need first. How about the arc length? AB, we have arc. Let me see. So what is the arc AB? Okay, the length of arc AB equals. We can see this. Do you remember in trigonometry we learned before? In trigonometry we have arc length is the radius times the angle theta in radius. Okay, in radian. Okay, now the radius is 1, and the angle theta is theta. Therefore, the arc length is equals 1 times theta is theta, right? Okay, so write the first. This is theta. The second result we need to use is what is BC. Okay, what is BC? Can we look at it? The small right triangle BCO. This is small right triangle. How do you find the BC? Of course, BC over OB is sin theta. OB is 1. Therefore, BC equals sin theta, right? Okay, good. Let me write it down to here. This is a sin at theta. One more. How about the AD? Okay, I'm going to write what is AD. Okay, AD, we have to look at the right, the big right triangle, which is DAO. What do we have? AD over AB, no, AD over OA is the tangent theta, right? OA equals 1. Therefore, DA equals tangent theta. That makes sense. Okay, so our direct rod is tangent theta. See, that's the results we need. And now we move to this step. Okay, so the first step, now we can see the relationship between arc AB and the BC and AD. Arc AB is controlled by BC and AD. Why? So let's look at the left. Arc AB is greater than BC. Arc AB is greater than BC. That's true, because BC is the shortest distance from the point B to OA, right? Definitely. So the second, arc AB is less than AD. Okay, arc AB is less than, excuse me, AD. Looks obvious. If we want to really to prove is this, arc AB is less than AE plus BE, and the BE is less than DE. Therefore, the arc AB is less than AD. That does make sense. Okay, which means from the geometry, from this graph, we definitely have these results. Another, now we directly give this. Why we have this? Because we just get the arc AB is the angle theta, BC is sin theta, AD is tangent theta. We just directly plug the results we just get into the first row, and then we get the second. Okay, good. Let's move to here. From here, we will go to the third row. How? Can you see the pattern? We're going to see sin theta over theta is controlled by cosine and 1, which means we're going to use squeeze theorem. Okay, we're going to squeeze sin theta over theta. And let me show you 2 steps. So the first is the sin theta over theta less than 1. All we need is use this part. Sin theta is less than theta. Okay, so I will going to write on the left side. What do we, excuse me, what do we have? Okay, can we see? And so hold a second. So I will going to get this. Okay, and I will write here because we have what? We have sin theta less than theta, right? Okay, it's easy. I just divided it by theta to the left, divided by theta to the right, and then theta and the theta we cancel. What do we have? I have 1. Can you see? Sin theta over theta is less than 1, so this part is true. The second is sin theta over theta greater than cosine. Is that true? Yes. All we need is use this theta less than tangent theta. Let me write on the right side. So this time, what do we have? First, we have theta less than tangent theta. What is tangent? I will write tangent is sin theta over cosine, right? And the cosine, this we're talking about theta greater than 0. Okay, cosine is a positive number, so at times cosine both sides. We have theta times cosine theta less than sin theta. Now I just divided by theta both sides, right? Divided by theta here, divided by theta here, and then we cancel the theta. See, what do we have? We have sin theta over theta greater than cosine theta, which means this part. Okay, so what do we have now? We have these results. That's the most important. Okay, we have these results. Okay, if we have this, which means we squeeze sin theta over theta, and then we look at the limit of the left side and the right side. The right side, of course, has limit 1, right? Because constant number. The left side, we definitely have the limit also 1 because of continuity of cosine. Cosine is continuous, so the limit equals cosine to 0, which means 1. And then can you see now by the squeeze theorem, so we do have the limit equals 1. Almost done. A little bit more. Okay, why? Because do you remember the graph that we draw? Okay, this graph that we draw, we call the theta is acute angle positive. Okay, how about the negative? Is negative this sentence, this statement is true? Yes, definitely. Why? You are going to verify it by yourself. Okay, sin theta over theta is an even function. Cosine theta is an even function, of course you know. Therefore, f at negative theta equals f theta. That's the result for even function, right? Which means this statement is exactly true. Even theta is a negative. If we plug negative theta, negative theta, negative theta, here is still true. Okay, is still true, which means theta no matter positive or negative. Okay, therefore why we finally have this result is always true. That's the proof. Okay, that does make sense. Look at this result, it's very beautiful. Okay, now all we need to do is going to practice 4 questions together. Let me see. Go back a little. So the formula, don't forget it. The pattern is sine at an angle over the angle. The angle approach 0. Okay, sin theta over theta. That's the pattern. Let me go to see the first step. Yeah. Look at the first. If we can do direct substitute, okay, because look at the bottom and the top are continuous function. If I direct substitute at the top, sine at 0 is 0. The bottom is also 0. Can you see? Okay, if we direct substitute, we get 0 over 0, which means what? It is indeterminate. Okay, so we have to do something else. How to do? Explore a little. We found that this function is very similar as the function that we just discussed, sin theta over theta. All the difference here is if 5x is theta, but the bottom is not theta. All we need to do is manipulate a little bit to make a denominator also see theta, which is 5 times x. Can you see? I was going to show you how to do manipulation. We said all we need to do is just do this. Manipulate a little, right? So I will going to just manipulate our function, so it looks very similar as the function in our formula. Okay, so what do we have? We will have this. That's the limit x approach 0. Okay, so what do we have now? The original is sine 5x, so the output. See, I was going to do this. Okay, I was going to do this. I was going to let me see the original 3x. I put here. I was going to times 5x to the denominator, times 5x to the numerator. Can you see? So, which means I did not change anything, right? You can cancel the 5x. Why are times 5x to the bottom and times 5x to the top? Because I want to make it the same theta in the first part, sin theta over theta. That doesn't make sense. This is all we need to do. Okay, so now it's better I put a big parenthesis. Okay, it's better I put a big parenthesis here. Okay, so now what do we do? I was going to cancel something to simplify. This x we cancel, and then 5 over 3 is a constant number. We have a limited law, right? Constant multiply law. We take this constant number out. See, what do we have now? Okay, so we can find that we can use the limited law now. Sorry, I was going to use the limited law. Okay, I was going to use the limited law to plug out the constant number out. So what do we have? We have 5 over 3, okay, times the limit x approaches 0, and then now we have a sine at 5x over 5x, right? Okay, so now someone you say this is almost the result. This limit is 1. Why? If I show a detail is 5x is theta, 5x is theta, we have to do substitute. Okay, substitution. Let me go to write this step down. If we want to exactly look at this as the formula is to this, to substitute. Okay, what kind of substitute? If I say u, no, I will not use u, I will use theta. Okay, because theta always talking about the angle. It's better use theta is 5x. If I do this substitute, so how about the x approach 0? So can we see? I just copy. And this time, when x approaches 0, okay, so everyone look at this. When x approaches 0, 5x, which means theta also approaches 0, right? So I change it, x approaches 0 to theta approaches 0. Okay, they are the same. Okay, theta approaches 0. Okay, what is our formula? Is sine at this time is theta, right? Okay, the bottom is theta. Is this the formula? This is the formula, right? Definitely. Okay, this is the formula which is 1. Okay, therefore we have the result is what? We have the result is 5/3 times 1. Therefore is 5/3. Okay, so this is the first. Okay, can you see all we need to do is what? Manipulate, right? Manipulate a little. Let me go to look at the second. A little difference. Can you see here? All the difference we can see is what? This time we have 2 sine. We don't have theta. Of course, you know what to do. Well, we're going to manipulate it again. Okay, manipulate it by divided by theta. Okay, plug in. But first, let me look at explore a little. Is this a indeterminate form? We cannot directly substitute. Okay, so someone you can try. If I try directly plug t into the function, that's 0 over 0. Sine 0 is 0. Sine 0 is 0. Okay, which means it's really the indeterminate form. All we need to do is manipulate it. It's the same, right? So now you can see all we need to do is the same as before. Manipulate. So we're going to manipulate it as the first time we did. Okay, let me go to show how to do manipulation. As here we have the limit t. Keep in mind that this variable is t. How to manipulate? I have to write a little bit longer. Okay, and the top is this is sine at 6t. The bottom is sine at 2t. How to manipulate? Okay, we have to do this. I have to divide it by this. You know, divided by what? Divided by theta, 6t, right? Okay, so if we are divided by 6t, and then what do we do? I have to times 6t, definitely. That doesn't make sense. Okay, if I do this, we make a sin theta over theta. That's all we need to do. Do the same to the bottom. Do the same to the bottom. Let me write here. Which means I have to divide it by 2 times t, right? And then times 2t. And then we cancel 2t. That's the original. Okay, so this is all we need to do for the manipulation. And now, what do we do? Easy. We're going to cancel something. Leave here. Okay, we cancel this t, we cancel this t, we cancel this 2, we cancel this 2. We have 3 left, and the 3 is the constant number, constant multiplier law we plug out. Okay, that limit law. Let me see put here. All we need to do now is the limit law, constant multiplier law. Okay, plug out the number 3. So 3 put here. And then now, what do we have? We have a big limit. Okay, let me write. So here is sine at 6t, right? Over 6t. And then the top is sine, at the bottom is sine 2t over 2t. Okay, so look, it's complicated, but don't worry. So this time we definitely have this is 1, this is 1. Why? Because of the limit law, right? So this is the quotient law. So going to, let me show you the quotient law. Now, okay, so I will put it here a little. I will write one more step. Can you see? So the limit law. All you know now is the limit is the quotient, right? Can say you the quotient law. What do we have? We will have this. That's 3 times a quotient. Okay, the top is the limit t approach 0. Okay, sine at 6t over 6t. The bottom is the similar, is limit t approaches 0 and sine 2t over 2t. Why we wrote this? Because now we have the top is a kind of a formula, the bottom is a kind of a formula. All we need to do now, you know, is substitute, right? Okay, so now we're going to here substitute. Wrote one more, but this time we have to substitute the 2 ways. Okay, so let me go into do substitution. Okay, substitute at the top, use x equals sec t is okay, right? The bottom, I substitute the y equals 2t, because we have 2 substitution this time. See, sec t is x, 2t is y. If we write this, and now we have the formula to use. So I put is 3 times here. So the top is limit, you know, when t approaches 0, x approaches 0, right? X approaches 0. And now is sine at x. Okay, so if I going to see, okay, is what? Is x, and here is x. Okay. What is the bottom? The bottom is limit x, no, sorry, is y, right? This is no longer x. And the y equals 2t. When t approaches 0, y approaches 0. So I have to change. Here is a y approaches 0. Now is what? Is sine at y over y. We wrote this. Definitely now we have the formula. This is a 1, right? The top. The bottom is also 1. So 1 over 1 is 1. Okay, see, we get the results now. What do we have? So this is so we can directly get it now. What the results is 3 times 1 over 1, right? Times. So the result is 3. Okay, that's the question. For these questions, a little bit different from the first. So you have to substitute in 2 steps. Let me look at one more here. What these results, what these questions ask, looks very similar, but all we need to deal with is the denominator. That you can see if we plug x equals 1 into the top, we get the sine 0, which is 0. Plug 1 to the bottom, 1 plus 1 minus 2 is also 0. So what do we see? And we see here is still 0 over 0, okay, which means indeterminate. So what do we have to do? Manipulate, right? So but how? All we need to do is look at it. Whereas theta, x minus 1, okay, theta approaches 0. So we have to make a denominator as also x minus 1. This time is easy because we can factor the denominator, okay? So let me look at this. We can directly just factor the denominator, okay? If I factor, we get x minus 1. So is the limit x approaches 1. If I were going to factor the top, I just copy. So the bottom, if I factor, I get x plus 2 times x minus 1. Okay, can you see? Have we get theta? Yes. Sine at theta, x minus 1 is theta, and this is also theta. So we definitely find the sine theta over theta, which means the formula. Okay, now we need to separate this fraction into 2. And how to use? We use the limit law, the product law. Okay, so we use the limit law. Okay, the product law. See, what do we have? We have this 2 limit term together. Okay, this is the limit x approaches 1. So the first part is 1 over x plus 2 times the limit x approaches 1. Okay, the second part is what we need. sine x minus 1 over x minus 1. Okay, the first part is easy. Directly substitute 1 out of 3. How about the second? You know the second is the formula, right? So what are we going to do? Substitute. Substitute here. I do this substitution. I use theta. Okay, I will use theta equals x minus 1. Okay, so if we do that substitute, see what do we have? We have the limit when x approaches 1, theta approaches 0, right? Okay, so you can see theta this time approaches 0. Okay, and then the fraction is sine at theta, right? Good. And the bottom is the theta. Can you see that the formula? That the formula, therefore we have the result is 1 out of 3 times 1 is 1 out of 3. That's this question. Also similar. So all we need to do is just to make this formula so we can do. The last questions here. This question is important because when we deal with the derivative of sine next the video, so we have to use this formula. We have to use the results from this question. So please pay attention how to get the limit of this. Let me see. All we need to do is what? To make a sine theta over theta. But you know, here we do not have a sine. All we need to do is make a sine, manipulate it still. Okay, so if someone remember in trigonometry, we learned how to manipulate this one. Times cosine theta plus 1 to the top and to the bottom. Okay, can we see? Of course, someone will say, can we substitute directly? Can we directly substitute the theta by 0? So let me go to see. Cosine 0 is 1. 1 minus 1 is 0, right? So here is 0 over also 0. Therefore, we cannot do because this is indeterminate form. So how to do? Manipulate. We always talking about this. Okay. Manipulate. So how to manipulate into our formula is this. So I'm going to see. I said we can times cosine plus 1 to the top. And then we can times cosine minus 1, the same number to the bottom. I will going to show you why we have to do that. Because to that we can merge this into sine theta. Okay, sorry, this is 0. Okay, this is 0, and then we have this a little bit longer. Okay, our times another. Can you see what do we have? The original is a cosine theta minus 1. So here is a theta. What do we times? We're going to times a cosine theta plus 1. Here we times a cosine theta plus 1. Okay, so what do we have now? Okay, it's better I put a big parenthesis. You can see I put a big parenthesis. Big parenthesis. This is true, right? Definitely. So I will erase this. Good. Our times big parenthesis. See what do we have? Okay, and at the top, so we can use the difference of squares, right? And at the bottom is just time together. Okay. Now all we need to do is use this formula. If someone remember, we call the difference of squares. Okay, we're going to use the difference of squares. We get the top is what is this. Now limit the theta approaches 0. The top is a cosine square theta minus 1. The bottom is theta times cosine theta plus 1. Okay, the top is what now? Okay, the top cosine minus cosine square minus 1 is negative sine. Do you remember? That's what we call the Pythagorean. So I will going to use a Pythagorean. Okay. I will use a Pythagorean identity. So we will have this. We will have this is the limit. Theta approaches 0. And a little bit longer. Negative sine theta square. Okay, that this makes sense. Do you remember this? Okay, so almost. Okay, and the -1, of course, the limit that we can poke out. And then sine theta square and the sine theta and the theta we can put it together is forming the formula. But so far, see, this is a kind of manipulation. If we do this kind of manipulate, we can change the cosine to sine, right? Good. And now we will do this. And we will just put here, separate, okay? We just separate a little. I'll put here, -1, it just put out. Separate a little, we will have a limit theta approaches 0. Sine theta, put the theta together, do you remember? So we put together and then times. Here is a sine theta, another tan theta. What do we have to the bottom? Cosine theta plus 1. See, we do this, we just, okay, it's better I put a parenthesis. Okay, we just separate this fraction into two fractions. So the first part is the formula. The second part we can find the limit directly. Now we can separate it into two limits, which means that the limit law we can going to use. Okay, we're going to use the limit law, the product law. Can you see what do we get? I will get directly this one. Okay, so here is a negative limit theta approaches 0. Okay, so here is sine theta over theta times the limit theta approaches 0. And the sine theta over cosine theta plus 1. Then now you know the first part is 1, right? Good. The first part is 1. So here is 1. So the second part, of course, we can use the limit law again. So let me see. The first part is 1, which means it is -1. The second part, if we use the limit law, quotient law, right? We use limit law again, quotient, or we can directly substitute. Okay, theta sin 0 is 0. Okay, cosine 0 is 1. Therefore, I plug in. What do we have? Here is 0. Here is 1 plus 1. You know what is the result? -1 times 0 is 0, right? Okay, so this is the result for this question. And next video we do have to use the results. Okay, cosine theta minus 1 over theta. The limit of this function is 0 as x theta approaches 0. Okay, that's all for this topic. Thank you, everyone. If you have any questions about this topic, please leave your comment. If you like this video, please subscribe to my channel for more videos. In the next video, we are going to deal with this one, the derivative of a trig function, which is a very important topic. See you next time. Have a nice day. Thank you. Bye.